All right, let's talk about one of the most confusing ideas in Java OOP, abstraction. We're going to cut through all the noise today and make this concept absolutely crystal clear.
And I know what you're thinking. If you have to sit through one more example about a car class that honks or an animal class that makes a sound, you're going to lose your mind. They just don't feel real, do they?
Well, forget all that. In this explainer, we are only using real-world systems, things that you might actually build as a developer. I promise you, no boring animals today.
So, let's get right into it. What in the world is abstraction? You know, the big idea is actually way simpler than most people make it out to be. At its absolute core, abstraction just means this. You show the user only what they need to see, and you hide all the messy, complicated stuff under the hood. The perfect example is an app you probably use every single day, Google Maps.
When you pop open Google Maps, you get this beautiful, clean interface, right? You see the directions, the roads, your estimated time of arrival. These are the essentials, everything you need to get where you're going. But what you don't see is the absolute chaos happening behind the scenes. You're not looking at complex GPS satellite calculations or the machine learning models predicting traffic jams or these crazy algorithms that are figuring out the best route. You just get the simple stuff you need. That is abstraction in a nutshell.
Okay, so how do we actually do this in Java? Our first tool is the abstract class. And the best way to think about it, truly, is as a blueprint for other classes.
The key phrase here is partial implementation. What makes an abstract class so special is that it can give you some methods that are fully coded and ready to go, while leaving other methods totally empty. It basically forces its children to fill in the blanks. So why on earth would you do that?
Well, let's imagine we're building a big logistics system. We have a parent delivery service class. Now, this class knows exactly how to do things like track a package or calculate sales tax. That logic is the same for every single delivery. But it has no clue how a specific delivery is actually made. It can't possibly know the details of a drone flying through the air versus a bike courier navigating city streets.
And this is what that looks like in code. See that track method? It's concrete. It's fully implemented because tracking is standard stuff. But then look at the deliver method. It's abstract. The parent class is basically saying, hey, I know every delivery service has to deliver, but I'm leaving it up to my kids, like drone delivery or bike delivery, to figure out the how.
Now for our second tool, and this is where things get really powerful in modern Java, the interface. Especially with Java 21 and beyond, interfaces are a total game changer.
See, they're not just these simple contracts anymore. Modern interfaces can have default methods that give you ready-to-use code, static methods that act like helper utilities, and even private methods to share logic internally. This makes them incredibly flexible and powerful.
So here's the crucial mental shift you need to make. Interfaces define what something can do, not what it is. Think about products in an online store. A t-shirt isn't a type of searchable thing, it has the ability to be searchable. It can also be returnable, discountable, or trackable. These are like little superpowers you can mix and match.
Take a look at this notifier interface. Of course, it forces any class that uses it to define its own send method. But look what it gives you for free. It provides a reusable log method, a handy validate utility, and even a private audit method. Any class gets all this awesome reusable functionality just by saying it implements this interface.
Okay, this brings us to the most important part of this whole explainer. This is where we're going to clear up all the confusion for good. Let's put abstract classes and interfaces head to head.
If you remember one thing from today, please let it be this. An abstract class is for an is-a relationship. A drone is a type of device. It's about identity. An interface is for a has the ability to relationship. A drone has the ability to be trackable. It's about capability. Abstract classes define a shared identity inside a family tree. Interfaces let you bolt on extra powers, and a class can have as many as it wants. That is the fundamental difference.
So now let's see how these two amazing tools work together. We're going to build a modern delivery drone and see how clean the design can be. First, we lay the foundation with a blueprint, the abstract class device. We know every device has to boot up, so we can provide a real, concrete boot method. But every device operates differently, so we leave the operate method abstract. Next, we define the add-on powers. We'll create a trackable interface and a rechargeable interface. These are just capabilities. I mean, think about it. Your phone or your car could also be trackable and rechargeable, right? They aren't tied to being a device.
And here's the magic. Our final drone class extends its core identity device, and then it implements its special abilities, trackable and rechargeable. It inherits its blueprint and then bolts on its superpowers. It's so clean.
So let's just break that down one last time to make sure it sticks. The drone is a device that's its core identity, its family, and it gets that from the Abstract class. And it has the ability to be tracked and recharged, and it gets those powers from the interfaces. This is what beautiful, flexible, modern object-oriented design is all about.
Okay, you get the concepts now. So let's wrap this up with some simple, actionable rules that you can take with you and use in your own code today.
Here's how you decide. If you're defining the core what it is for a family of related objects, use an abstract class. If you're adding what it can do capabilities that could be mixed and matched across different kinds of objects, use interfaces. And just remember that golden rule. A class can only have one parent, but it can have as many superpowers, as many interfaces as you want.
So, now that you have this really clear model of identity versus ability, the only question left is, what amazing, flexible, powerful systems are you going to go build? Thanks for tuning in.